Hello, class. Okay, so today's lesson is once again the same section on slope. However, here we're going to learn how to visually assess slope. So in other words, we're looking at a graph, we're looking at the geometric representation of a linear function, a straight line, and just by looking at it, we can tell if it is positive, negative, zero, or undefined. In the last class period, we were taking a look at zero and undefined slopes, positive and negative. So you should maybe have starting to be getting a feel for exactly what these would look like. But I want to sort of go into this more concretely. So let's take a look. How can we tell if a slope is positive, negative, zero, undefined by just looking at the graph? So, all right, a positive slope. The line is increasing from left to right. Now, the left to right thing is very important. We always assess slope from left to right. So we start out on the left-hand side, and then as we travel right, the line is increasing or going uphill. Negative is the same, but opposite. The line is decreasing from left to right. So from left to right, the line is going down or downhill, decreasing. Zero is a horizontal line, and undefined is a vertical line. Okay, so you should be filling all these in your notes packet. So it's fine to fill these in, just see those words, but I think that once you sort of look at a couple of representations, you should be, with some practice, be able to see this very easily. So let's take a look. First, positive slope. Now I'm just going to choose any 2 points that are on this line here. This line is positive. As you can see, if you go from, ba, 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 yes, you go from left to right. So that's in the direction of the arrow that I just drew. You're going uphill. In other words, as x is increasing, y is also increasing. So you're going right, increasing, increasing, y is also increasing. You can, like, once again, left to right, it's uphill. So let's take 2 points, and I'll try to be concrete about this. But I'm going to choose this point in here and that point in there, and I'll label them what they are. This point, they're the x and y intercepts, but one of these points is 0, 6, and then we also have the point negative 4, 0. Okay, right, so those 2 points there. Now, how can we assess that this is positive without looking at it left to right? Well, we can prove it simply from the formula for slope, otherwise known as m is equal to y2 minus y1 over x2 minus x1. Get out of there with that box, or not. At any rate, okay, so if I'm filling in these values for x1, y1, and x2, y2, we have 6 minus 0 over 0 minus a negative 4. Now, if I am calculating this, of course we know concretely this is 6 over 4, but we don't even need to solve this here and or reduce this, even though I'm just going to, for clarity's sake, reduce this to 3/2. But we know it's a positive number, so that's how we can tell. We can prove, given 2 corner points that are on the line and calculating the slope using the formula we learned in the last class, that this is a positive number. 3/2 is a positive number. So same thing for negative. Negative. Okay, so I'm going to use the intercepts once again. Actually, no, I'm going to use different points on the line here. So let's say I'm going to use this point here, which just pretend that that's a point and not just a gobbledygook little line there. And we're going to say that this is the point negative 5, 5. Okay, another point on the line. We'll use this one down here, and I'm going to say that that is 7, negative 2. Okay, so once again with the slope calculation, I won't write out the formula, but this is m, the slope, is equal to 5 minus a negative 2 over negative 5 minus 7. So I'll just bring this calculation down here so we don't run into the graph. 5 minus a negative 2, 7. Negative 5 minus 7, negative 12. Negative 7/12 is the final reduced answer, and once again, it's negative. You can clearly see that if your eyes are traveling from left to right in the graph, that this is a downhill slope and or it is decreasing from left to right. Okay, same thing for 0. So let's just choose these 2 points here. I'm going to choose 4, 3, and then I'm going to choose negative 6, 3. Okay, so once again, formula for slope. M is equal to 3, whoops, 3 minus 3 over 4 minus a negative 6. All right, so this reduces. 3 minus 3 is 0. 4 minus a negative 6 is 10. 0 divided by any number is 0. So we know that slope is 0. Great. Excellent. So when the numerator, or the change in y, the vertical change, is 0, we know that's a 0 slope, and that makes sense. Is there any change up and down in a horizontal line? No, there is not. There's no change up and down. Therefore, that value is 0. 0 divided by any number. It doesn't matter which 2 points I chose. I could choose points that are closer together. That would just mean the denominator was 2, 3. So it'd be 0 over 2, 0 over 3. Still evaluating as 0. Last one, undefined. An undefined slope, and I'll choose 6, negative 6. And I'm also going to choose the point, just to make it easy on myself, 6, 6. So for slope here, we have 6 minus a negative 6. That evaluates as 12. And then 6 minus 6 is 0. So we have 12 over 0, 12 divided by 0. 12 divided, if I take any number and I divide by 0, we cannot divide by 0. Therefore, this answer is undefined. So an undefined slope is a vertical line. Now, what I want you to do is for these next couple sheets, just draw in for this next one a 0 slope. Draw in a positive slope, draw in an undefined slope, and a negative slope. Multiple classmates can have multiple different lines. It can literally be any line with a negative slope, any line with a positive 0, undefined slope, etc. So I just want you to draw in a line in these next 4, just so I know that you understand what you're doing, and that we can check to see that you have not only watched the end of this video, but also know and understand the work. Okay, everybody have a great weekend, and we'll see you on Monday.